Right, this is question 5 of the maths paper in 2022 for mechanics. So look at a particle at an angle of alpha. What we'll do is we'll look at the vertical parameters that we know. So u equals u sine alpha, s equals 0. So that's for the distance displacement, which is 0. A equals minus 9.8, v equals question mark. Horizontal, u equals u cos alpha, s equals 120, a equals 0, there's no acceleration going on. And so what we can use here is s equals ut plus a half at squared to work out t. So t equals 120 over u cos alpha. And with that, we can then use the same equation on the vertical. So 0 equals u sine alpha t minus 4.9 t squared. Substitute t into that equation, and what do we get? Yeah, write it all out. And what we can then do is multiply both sides by u cos alpha over 120, and then you're left with u sine alpha minus 4.9 times 120 over u cos alpha. Right, and you're nearly there. So put u sine alpha to equal 4.9 times 120, which is 588. And all over u cos alpha, and then put u cos alpha over the other side, and you get u squared sine alpha cos alpha. Come on, write it properly. Come on, you can do it. Yes, equals 588. There you go. That's proof in the first part A. Okay, second part, we need to find out, we're given a vertical height that it reaches is 10 meters, and we've got to show u squared equals 1960. So again, let's write down what we know on the vertical side. We know distance is 10 meters, so let's write that down. Okay. Meters, okay. And now we're going to put the information we know. S equals 10. And at that height, actually, it's maybe useful to know, you may not need to, it's the horizontal distance is 60 meters. So just bear that in mind. It may be something we can use later, but not necessarily. Acceleration is minus 9.8, and yeah, we can use t from above 120 over u cos alpha. But and it's going half the way, it'd be divided by 2, so it'd be 60 over u cos alpha. Right, so easily mistaken. Okay, and you've got a u as well. You probably can, well, v equals 0, yes, you know that, and u equals u sine alpha. So v equals 0 at the top, basically stopped for an instant. So you can use a v squared equation. V squared equals u squared plus 2as. Okay, so plug the values in. V squared is going to be 0, u squared is going to be u squared sine squared alpha, right? And minus 19.6 times 10, the distance, sorry, minus. Yep. Okay, so u squared sine squared alpha equals 196. Okay, now this is the trick. So you don't know what sine squared alpha is, but what you do know is from the previous proof, it's always useful to use what you've had from before. Okay, so I'm going to say u squared equals 196 over sine squared alpha, but you've got the equation you figured out before, u squared sine alpha cos alpha equals 588. Remember, this even in GCSE they used to do this, say, oh, here's part A, and use this or what or not to find part B, and you generally need to use it. So you plug in 196 over sine squared alpha into this equation for u squared, and put in the rest. And you can see there's going to be some things you can cancel out. So let's cancel out the sine alphas, and you're left with 196 over tan alpha is cos alpha over sine alpha is tan alpha equals 588. Okay, tan alpha equals 196 over 588, and then this will help finding out what sine alpha is. Okay, so using a triangle and using Pythagoras, you can work out the hypotenuse. So that's what we need to do. So square root of 588 squared plus 196 squared. Okay, and then all you have to then do is sine alpha equals basically that number, 196 over that number. Okay, and just calculate that out and I'll put it down to be complete. Equals 619. Okay, so now we need to, okay, so sine alpha is 196 over 619.806, and what we need to work out is sine squared alpha, 196 over 619.806. Okay, and then sine squared alpha, you just plug that in your calculator, you'll find that that is going to be 0.1, basically two significant figures in fact. So u squared equals 196 over 0.1, which is 1960. So done. Okay. The next part of the question, so those are the two hard bits actually of that question. So if you did that, you get method marks if you didn't get quite the answer, but if you got that, well done. I think that's a hard question. Right, second part was about air resistance and the effect on V if V is going to be greater than U. I would say yes, because you would need to hit it harder. The initial velocity has to be higher to reach the B, otherwise you won't reach B, because the air resistance will slow it down, okay, at a faster rate. Okay, so it won't reach a distance up to B. All right, D, saying how would you model it in real life, a more realistic scenario. I would say they've been using a particle, and a particle has no, three-dimensional elements to it, so I would say model it as a golf ball. It's got, a round shape with dimples, and this could affect the movement through the air. So that's what I would say. And I think that's it, and well done guys. It was a hard paper, but well done for completing it. Please like and subscribe. Thank you.